Today's lecture will cover fluoroscopy. Fluoroscopy provides dynamic, live imaging, which shows changes as structures change. Routine radiography utilizes static images, whereas dynamic imaging demonstrates functions, structures, and pathology. Thomas Edison invented the fluoroscope in 1896. Technically, what Röntgen discovered was fluoroscopy. This requires a specialized tube with the image receptor. With fluoroscopy, the tube that is emitting radiation is below the patient, not above like traditional radiography. Initially, many early scientists using fluoroscopy received full primary beam to the face and eyes. After realizing the biological effects, the tube was mounted to the table system and used mirrors to project the image from the primary beam. Image intensification tubes were developed in 1948. This system used video cameras and monitors to view images. Today, thin film transistors are used in digital fluoroscopic systems with post-processing abilities. Fluoroscopy can be used for upper gastrointestinal, lower gastrointestinal, and small bowel studies to view the esophagus, stomach, small intestine, or large intestine as contrast is passed through. C-arms are portable fluoroscopy units used in surgical suites, patients' rooms, and the emergency room for the placement of lines, ports, pacemakers, and to check for fracture alignment. The tube and IR are mounted in a C shape to ensure permanent alignment. The arm can be raised, lowered, rotated, and moved along the length of the body. The typical designs include the under-the-table units and over-table units. A carriage supports the equipment that is suspended over the table. For under-the-table units, this would include the image intensification tube. For over-the-table units, this would include the X-ray tube, as well as the controls, tube shutters, and a spot imaging device. Fluoroscopic tubes are designed to operate for longer periods of time at lower MA settings. For diagnostic imaging, the tube MA is typically 50 to 1200. For fluoroscopic imaging, the tube MA is 0.5 to 5 MA. The SOD must never be below 15 inches. Fluoroscopy can be operated by a foot switch or controls on the carriage. Early fluoroscopic equipment used screens which required an adjusting period for the rods of the eyes to become activated. Developed in 1948, image intensification allowed the brightness of the image to be increased to daylight levels. The purpose of image intensification was to amplify the brightness of the image. The primary beam strikes the input screen after passing through the patient. The fluorescent screen absorbs the X-ray photons and emits light photons. The photocathode absorbs light photons and emits electrons, and then the electrons are accelerated toward the output screen. The input screen is a concave structure typically made of glass, titanium, steel, or aluminum, and is coated with cesium iodide phosphors. The tightly packed phosphors absorb approximately 66% of the incident beam. Electrostatic lenses are a series of negatively charged electrodes inside the glass envelope of the tube. The purpose is to accelerate and focus the electrons passing from the input screen to the output screen. Magnification tubes electronically magnify the image by changing the voltage on the electrostatic lenses. These are also called multi-field, dual-field, triple-field, or quad-field intensifiers. They are capable of 1.5 to 4 times magnification. The magnification factor formula is input screen diameter divided by the diameter of the input screen used during magnification. When using magnified mode, collimation is not activated. Resolution increases when magnified mode is used.